Next topic is complex functions. Functions of complex variables. Functions of complex variables. Here, what is this? Z equal to x plus iy. Z equal to x plus iy is the complex variable. Is the complex variable. Here, what is real part of z? Real part of z is what? X. And the imaginary part of z is what? Y. You know this. Okay, basic concepts. Z equal to x plus iy is the complex variable, and real part is x, imaginary part is y. See, in real variables, not complex. Okay, in real variables, x is the variable, and y is function of x. If I write y equal to x of x, f of x, y equal to f of x is real function. That means what? Y is a function of x. Y is a function of x, is a real function. Y equal to sine x, y equal to e power x, like that. Here also, here now in place of y, w, and f of, in place of real variable x, complex variable. Here w equal to f of z is called, here it is called real function. Now this is called complex function. This is called complex function. And since it is always, what is meant by complex variable? It is in complex variable means what? It must possess one real part and one imaginary part. The real part and the imaginary part. Therefore, this w is a since w is a complex function. W is a complex function. W is a complex function. It has the form w equal to what? Some real part plus some imaginary part. W equal to u is the real part and v is the imaginary part. And what is clearly, this is u and v are not constants. These are functions of x or constants. W equal to u of x comma y plus I into v of x comma y. Therefore, w equal to f of z. Therefore, the complex function can be written as complex function. Can w equal to f of z can be written as w equal to, what is this? W equal to actually what? U xy plus I into vxy. And what is it is equal to f of z? What is f of z? X plus iy. Simply one can write this as, u plus iv equal to function of x plus iy. Function of x plus iy. W equal to, this is the complex function explicit form. Complex function explicit form. That is, w possesses how many variables completely. Therefore, complex function has how many variables? Therefore, complex function has how many variables? Has the variables. What are those? X, y independent variables. X, y, and u, v are dependent on x, y. U, v are what? Functions of x and y. U, v are dependent variables. X, y are independent variables. So totally how many variables are here? 4 variables are there. And one important point is the complex function w equal to f of z. The complex function w equal to f of z represents a transformation. The complex function w equal to f of z, that is u plus iv. W is u plus iv, and z means x plus iy. Represent a transformation or mapping. It is also called as mapping. Mapping from where to where? transformation or mapping from z plane. Mapping from z plane. Z means what? X plus iy. Contains x comma y. Contains x comma y variables. Contains x comma y variables. Okay. From z plane to, this is called w plane. W plane means what? Contains uv variables. Contains u comma v variables. So what is this? The complex function w equal to f of z or u plus iv equal to f of x plus iy represents what? It is a function or a mapping or a transformation from where to where? From z plane to w plane. From z plane to w plane. Once again, let me explain the concept. You know, complex variable. Coming to complex function, like a real function y equal to f of x, there is a complex function w equal to f of z. W equal to f of z. Since w is a complex function, it must has the form complex nature. That means real part plus imaginary part. So w has taken of the form w equal to u plus iv, where u and v are functions of x and y. Therefore, w equal to f of z, this function can be written as what? U plus iv equal to function of u plus iv equal to function of x plus iy. So this entire complex function contains how many variables? 4 variables. X, y and uv. X, y are independent variables. Uv are dependent on x and y. And what is the original meaning of complex function? Original meaning of complex function, it represents a transformation from z plane. Z plane means having xy coordinates to over w plane having uv variables. For example, see. For example, take w equal to choice reverse, whatever it is, w equal to z square. W equal to z square. It is a complex function. That means what? U plus ivw, and z means what? X plus iy whole square. That is u plus iv equal to x square plus b square. B square becomes minus y square plus I into 2xy. I into 2xy. Therefore, what is u value? X square minus y square, and the v value is what? 2xy. V value is what? 2xy. Now the thing is here, I'm taking this as z plane. This is z plane, and this is w plane. In w plane, what are the variables? U and v. In z plane, what are the variables? X and y. Now you put x equal to 0 comma 0. This is the point. When x equal to 0 comma 0, what is u and v? 0 comma 0. So this is the point. O, I'm taking o dash here. This is the point. When x equal to 1 0, for example, I'm taking 1 0. Where is 1 0? This is 1 0. For example, x equal to 1 0 I'm taking. When x equal to 1 comma 0, this is the point. What is the image of 1 comma 0 on w plane? Put x equal to 1 0 here. U equal to 1 and v equal to 0. U equal to 1 and v equal to 0 means this is also same point. This is also same point. If I take 1 comma 1, this is the point 1 comma 1 in x coordinate, xy plane, that is z plane. 1 comma 1 means what is u value? 0. U value 0 and v value what? 2. That means this is the point. What is its image? 0 comma 2. Its image, this is, I'm taking a. So this is a dash. If I take this point b, this is b dash. This is b dash. Then if I, for example, if this is the triangle, image of the points joining 0 0 1 0 1 1, what is its image? Exactly, this is the image. This is the r and this is its image r dash. That means this is a mapping from where to where? This is the mapping from where to where? Z plane to w plane. Mapping or function. But this is the concept of complex function. This is the concept of complex function. And the next definition. Any doubts in this one? Complex variable. Next, what about the complex function? So, and see, all of you, the one important point is what here? Why I am taking two planes, z plane and w plane, to represent w equal to f of z. This function w equal to f of z, because 4 variables are there. For 4 variables, is it possible to draw a single graph? That means I need 4-dimensional plane, 4-dimensional space, having 4 axes, which are mutually perpendicular to each other, x, y, u, v. It's not possible to draw on the paper. That is why what the scientists did, they separate 2 planes. One is z plane, which is having x, y variables, and another one is w plane, which is having u and v. And according to this relation, u and v, functions of x comma y, the mapping is from z plane to w plane. Mapping is from z plane to w plane. This is the concept of complex function. Now, the next one is limit of a complex function. Limit of a complex function. Theory. Let w equal to f of z be a complex function. Be a complex function. Be a complex function and single valued. You write like this. Be a single valued complex function, not multiple values. The function is having single valued complex function. Single valued complex function of z defined over the domain. Defined over the domain, some region R, exactly like this one, defined over the region R. Okay, then you write like this, defined over the domain R, having I will not tell the neighborhood now, so you write like this, having a point z equal to z naught, having a point z equal to z naught. Here the function f of z, here the function f of z may or may not be defined, may or may not be defined, may or may not be defined at z equal to z naught, at z equal to z naught. Then the function f of z is said to have a limit L as z approaches z naught, if, when it is possible, if given any arbitrary small real number epsilon greater than 0, there exists epsilon greater than 0, there exists a real number, delta greater than 0, such that now mod f of z minus L is less than epsilon whenever z minus z naught is less than delta, z minus z naught, z less than delta. Here L is finite, real number. Okay, it is also denoted as, we can also represent this as denoted as limit f of z as z tends to z naught is equal to L, as z tends to z naught equal to L. If such number L does not exist, limit does not exist. Now Once again, I am explaining the concept. Now, what is the limit of a function? And before going to deal with the limit of a complex function, let me write in. Do you remember limit of a complex real variable, real function? In our first semester topic, limit of a series, limit of a sequence, limit of a sequence. What you did there? Limit an equal to some L as n tends to L infinity, I think we have taken there. But let me explain in the functions. For a real function, what is this limit? F of x as x tends to x naught equal to some L. What is the theory here? When x approaches x naught, f of x approaches L. F of x approaches L. This is real theory. Limit, what is this? When x is approaching x naught, x is approaching x naught, then f of x is tending to what? L. That means what? The difference between f of x and L is very small. Epsilon means what? A small positive real number. When f of x and L both are approaching together, this is when what is the meaning of? When f of x and L, the distance between these two is very, very small. Whenever this x approaching x naught, that means the distance, the mod is less than delta, means very, very small. That means what? When the distance between x and x naught is very small, then the corresponding f of for x, the corresponding function is f of x. The distance between f of x and L is also very small. That is called approaching limit L. F of x is approaching limit L. Now here also same thing. You keep this mathematical representation in mind. What is the meaning here? When z is approaching z naught, z is approaching z naught, f of z is approaching L. F of z is approaching L. That is why what I can write? F of z minus L. F of z is approaching L means the distance between these two is very, very small. Whenever the distance between z and z naught is also very small. These are small positive real numbers. Exactly, that is given here. That is given here. I think you can catch this definition. Once again, limit of a complex function. L is said to be limit of the function f of z as z tends to z naught. As z tends to z naught. How we can interpret this? When z minus z naught is the distance between z and z naught is very, very small, the distance between f of z and L also very, very small. Very, very small. Then f of z approaches L as z approaches z naught. Z approaches z naught. This is the definition of limit. And the difference between limit concept of real variables and limit concept of complex function is what? This is the concept is here. The concept is here. In real variables, x tends to x naught. What is the meaning of x tends to x naught? Is along a real line. Is taken along a real line. From left side or right side. From left side or right side of x naught. That means what? Limit x tends to x naught. F of x means what? This is all the values must be same na? Limit concept. Left limit and the right limit. X tends to x naught plus f of x. That is what? If this is the point, for example, x naught is the point. This is right and this is left. That means this is what axis? X axis. That means this limit approaches, this limit x tends to x naught approaches along a real line only, real line through left side or through right side. X is approaching x naught. But this is important. But in complex variables, z tends to z naught. Z is tending to z naught. Z means what? Z means what? Complex variable. That means what? Complex variable having how many variables? two variables x and y, x and y. Okay, z tends to z naught along any path, joining z and z naught, that is, I will show in the figure. What is z means x and y terms are there. For example, if I take z here, that means what? X plus iy. Z means what? X plus iy. Okay, that is x plus iy can be taken as what? X plus iy can be taken as the point x comma y. Okay, you know this. And z naught I am taking here. For example, this is z naught. Z naught point is x naught comma y naught. Okay, now the thing is here, z is tending to z naught through a straight line, or through a parabola, or something, a path like this, okay, or it may be any path like this. That means all these paths, and along any path, joining z and z naught, the limit value must be same. The limit value must be unique. Then only limit exists. This is the main property in complex variables. What is that? The thing is here, in real variables, x is approaching x naught along only a straight line, along a real line, along a line only. But in complex variables, z is approaching z naught along a straight line, or maybe parabola, or maybe along any curve, along any path joining z and z naught, Okay, then just wait, along z and z naught. Now, and along any path, the limit value must be unique. Okay. Now, this is the concept of limit. Any doubts? This definition of limit. Okay, I will write this one. The definition mod when z minus z naught less than epsilon, 0 less than z less epsilon, when z minus z naught less than epsilon, f of z minus L, f of z minus n less than epsilon. The definition is called delta-epsilon approach. Okay, whenever I use delta and epsilon approach, this is called definition of a limit using delta-epsilon approach. Now, just one small problem based on delta-epsilon approach, but it is somewhat complicated. Using the definition of delta-epsilon approach, show that limit z tends to I, z square equal to -1. Proof. What is it? Automatically you can substitute z tends to I square value -1. But what we have to prove using delta-epsilon approach. Here, what is the first definition? See, here f of z is what? Z square. What is L value given as? -1. And what is z naught is given as? I. And what is the theory definition as per this one? We want to determine, L is given, everything is given. So I have to determine delta and epsilon. So we want to determine a real number delta, which is greater than 0, such that such that for a given real number epsilon, for a given real number epsilon greater than 0, what we have to prove? Mod f of z minus L less than epsilon whenever 0 less than mod z minus z naught less than delta. Mod z minus z naught less than delta. Now, first part, what is this one? See, okay, see, this is f of z, this is L. So what is f of z minus L? Mod f of z minus L less than epsilon implies what? F of z is what? Z square. L value negative 1. L value negative 1. So mod z square plus 1 less than epsilon. Mod z square plus 1 less than epsilon whenever what is this thing? 0 less than z minus, what is z naught? Z naught is I. Mod z minus I is less than delta. Is less than delta. Okay, I have to prove this. Now, let me check first. Z square plus 1. Mod z square plus 1 less than epsilon implies this z square plus 1 can be written as, what is this? Z minus I into z plus I. Z plus I less than epsilon, right? This implies I will write mod z minus I will write this is mod z minus I plus 2i. I will write less than epsilon, less than epsilon. Now what is this is? Okay, I will not write this less than epsilon is here now. So let me clearly explain this. First thing, this is equal to, this is equal to, and this is also equal to, right? Now what is mod z minus I? Z minus I is less than what? Delta. So I can write, see, so less than delta I will write, since mod z minus I less than delta, mod z minus I less than delta. So what is this is? Less than, this is what now? Less than delta, less than delta. And what is this part? This part is over. This is also what? Delta. This is z less than delta plus this is 2. I can write one more step to get for this. What is mod? This is mod x plus y. Mod x plus y is less than or equal to mod x plus mod y. Mod x plus mod y. Using that concept, I can write this is less than or equal to, this is less than or equal to is here, less than or equal to mod z minus I, and coming to this part, I am applying this principle. This is x and this is y. So this is mod z minus I plus mod 2i. Any doubts? This is bracket. This one, there is no change in this one. Okay, applying this principle, mod x plus y principle for this mod second term. Now what is this is? Mod z minus I is what? Less than delta. And here also this is less than delta plus mod 2i becomes what? 2 only. Mod 2i is 2 only. This is the expression for what? Mod z square plus 1. Mod z square plus 1. But what we have? Mod z square plus 1 is, mod z square plus 1 is less than epsilon is given. Less than epsilon is given. That is, therefore, what I have? Delta into delta plus 2 is less than epsilon. That is, delta square plus 2 delta less than epsilon. Delta square plus 2 delta less than epsilon. I can write a plus b whole square means delta plus 1 whole square. Sorry. This is 2 delta. Delta plus 1 whole square minus 2 delta 1 less than epsilon. So delta plus 1 whole square less than epsilon plus 1. So what is delta plus 1 now? Delta plus 1 is less than root over epsilon plus 1. So what is the delta required value? For any given epsilon, this is the value. For any given for any given epsilon, this delta value must be less than, with this choice of delta, with this choice of delta, what we get? Definitely with this choice of delta, definitely the definition is satisfied. That means what? Mod z square plus epsilon less than epsilon whenever 0 less than mod z minus I less than delta. Z minus I less than delta. And once again, I will explain this problem. Delta epsilon approach. First identify what is f of z and what is L and what is z naught. And what we have to find, this is important. Here we have to find only delta for a given real number epsilon. We are not finding epsilon value. We are finding delta value. Delta value satisfying this definition. Mod f of z minus L less than epsilon whenever 0 less than this definition. So first I am considering this L epsilon. So what I have to prove? Mod z square plus 1 less than epsilon whenever mod z minus I less than delta. So to get this delta value, I'm considering first this z square plus 1. So separating into a minus b into a plus b, a minus b into a plus b. Then I'm writing every term big, and remember one more point. Why I'm converting to z minus I? Here z minus I terms are there. So convert everything to z minus I because I know z minus I is less than delta. So convert this expression into z minus I terms. That is why I have written z plus I in terms of z minus I plus 2I. Now mod x plus y formula is less than or equal to mod x plus mod y. So this equal to becomes less than or equal to this term as it is, and this is x value, this is y value. So mod x less than or equal to mod x plus mod y. Now and mod z minus I is what? Less than delta. So this is delta less than or equal to becomes what? Less than. And this is delta and this mod 2i is 2. So what I am having already for mod z square plus 1 is less than epsilon for a given epsilon. Therefore, this delta into delta plus 2 definitely less than epsilon. So simplifying this, I'm getting delta value. What is this delta value? Under root epsilon plus 1 minus 1 for a given epsilon. So with this value of delta, this definition is satisfied. Therefore, limit z tends to I, z square value is negative 1. Z square value is negative 1. Okay, this is one approach, delta epsilon approach. Now you solve this problem assignment using delta epsilon approach. Show that limit z tends to I, mod z square minus z equal to I minus 1. Same logic, get z minus I terms into the picture. And next question is no need. Now another approach, you take find the value following limits. You can find directly, doesn't matter, right? Another approach is to find limit is along any path joining z and z naught. This approach, let us see. You know this technique. In last, I think in first semester I told this one. The first problem is First problem is check the limit. Check whether limit exists or not. First question. Limit z tends to 0. Z by mod z. Limit z tends to 0. Z by mod z. See, I'm approaching. What is this one approach? Joining along any path, joining z and z naught. Here, f of z is what? Z by mod z. And z naught is what? 0. Z tends to z naught. Z naught is what? 0. Right? Now, take choice reverse. Along two paths. Any two different paths. Along any two different paths. Take z tends to 0 along any two different paths. Along any two different paths. Any two different paths. First part, this is first one. Choose the path. Choose the path y tends to 0. Choose the path y tends to 0, followed by x tends to 0. Followed by x tends to 0. What we get then? What is the meaning of this? Choose the path y tends to 0, followed by x tends to 0 means first apply y tends to 0, then apply x tends to 0, then apply x tends to 0. So first limit x tends to 0. What I have to first apply? Limit y tends to 0. What is that? Is nothing but x plus iy by mod z is nothing but what? Mod z, you know, all these complex variables, intermediate, you know, mod z means root of x square plus y square. Okay. Now, if I apply this, limit x tends to 0. First, y tends to 0. If I apply, what I'm getting? X by root x square. Y becomes 0. X by root x square. Done. X by root x square means what? Now, limit x tends to 0. X by what is root x square plus or minus x? Therefore, I will write mod x. I will write mod x. This is plus or minus x. Nothing but mod x. Okay. So what is this limit now? Problem becomes what? Real variables. Problem becomes what? Real variables. This is plus or minus 1. This is plus or minus 1. Still any doubt? Limit x tends to 0 plus x by mod x. Limit x tends to 0, x tends to 0 plus means positive, mod x value positive, 0 minus x by mod x, that is limit x tends to 0, x by minus x, when x approaches 0 minus, so negative 1, so value is plus or minus 1. Now choose the path. Now choose the path x tends to 0 followed by y tends to 0. X tends to 0 followed by y tends to 0. What we get? We get limit z tends to 0, z by mod z is equal to, what is the first one? First one, this is inside. What is first I have to apply? X tends to 0. X plus iy by root over x square plus y square, and what is this outside limit? Y tends to 0. Now if I apply this is limit y tends to 0. When x value 0, what is this becomes? Iy will be there and root y square will be there. So this is equal to limit y tends to 0, iy by mod y. Iy by mod y. What is this value? Same logic, plus or minus 1 multiplied by I, plus or minus I. Both the limits are changed since along two different paths, the limit value is not unique. The limit value is not unique. Therefore, limit z tends to 0, z by mod z does not exist. Does not exist. Okay, this is one model problem. Any doubts in this one? Or see, along any paths means you can take y equal to mx also. You substitute y equal to mx, y equal to mx, and what this becomes? See, r. I will tell one more. Take the paths. Take the path along y equal to mx, passing through, compulsory this must be passing through this point, passing through 0, 0, passing through z0. Z0 is 0, so nothing but 0, 0. How many paths are here? Take the path along y equal to mx. Here m is parameter. M is parameter. What is the meaning of this? Y equal to x is one line, y equal to 2x is one line, y equal to 1 by 2x is another line. So many lines are there passing through origin. I have to get unique limit. So what is this becomes? Z equal to x plus iy. Z equal to x plus iy. So limit z tends to 0, z by mod z is equal to limit x plus iy by root of x square plus y square. That is equal to limit x plus, what is y equal to mx? So I will write, just wait, it's stuck. Yeah, this is y equal to I mx by x square plus m square x square under root. This is now what? All the terms are in terms of x, therefore limit x tends to 0. You can write here x comma y tends to 0. Now limit x tends to 0. What is the common? X common. So 1 plus im by, what is this also? X square common outside x. X terms gets cancelled. Limit x tends to 0. It depends on the value of m. On the value of m. Therefore, limit depends on m value, which is not unique. That is, if I take m equal to 1, y equal to x line, y equal to x line, m equal to 1, then I will get one answer. If I take y equal to 2x, then 2. If I substitute to another limit, limit depends on m value, which is not unique. Which is not unique. Therefore, limit is not unique. Limit is not unique along any path. Along any path. Therefore, limit does not exist. Therefore, limit z tends to 0. Z by mod z does not exist. Does not exist. This is one way of proof. Okay, y equal to mx model. Now, another one. Check the limit. Limit z tends to 0. Real part of z minus imaginary part of z whole square by mod z square. Mod z square. Okay. Now z means what? X plus iy. Z equal to x plus iy. So real part of z is nothing but x. Imaginary part of z is y. Okay. Therefore, limit z tends to 0. Real part of z, imaginary part of z whole square by mod z square is nothing but limit z tends to 0. This is x minus y whole square by mod z means what? Root. Square is there. Therefore, x square plus y square. X square plus y square. Okay. Consider now, you better use along z tends to 0. Take the path y equal to mx. take the path y equal to mx, passing through what? Definitely it must passing through this z naught, passing through origin, passing through z naught, that is this one. Then what is this becomes? Limit z tends to 0, x minus mx whole square by x square plus m square x square. So limit only x terms are there, x tends to 0 I can write. Okay, this is nothing but x comma y tends to 0. Okay, now x gets cancelled, 1 minus m whole square by 1 plus m whole square, which depends on m, which depends on m, which is not unique, which is not unique. Therefore, limit does not exist. Therefore, limit does not exist. This is one model problem. And another one, limit z tends to 0. What is this problem? 1 by 1 minus e to the power of 1 by x, 1 by x plus iy square, plus iy square. Now solution. Your choice is yours. I will take along the first case. What is that? Passing through y tends to 0 followed by x tends to 0, or x tends to 0 followed by y tends to 0, whatever it is. Okay, let me consider the path y tends to 0 followed by x tends to 0. So what we get? Limit z tends to 0, 1 by 1 minus e power x plus iy square equal to, first what is the limit? Y tends to 0. Y tends to 0, 1 by 1 minus e to the power of 1 by x plus iy square, and x tends to 0. So after applying y tends to 0, what I am getting this one? 1 by 1 minus e power 1 by x as it is, and y square value 0. So I will get this. Now what is this limit value? Anyone? What is this limit value? This when x is positive, when x tends to 0 plus e to the power of 1 by x tends to what? 0 plus. 0 plus means positive value. 0 plus means positive value. Then what is this value? E power 0. Anyone? Yes? When x tends to 0 minus e to the power of 1 by x tends to what? Negative. This is negative.
0.
E to the power of 1 by x is, this is x tends to 0, this is 0. And this is what? X tends to 0 plus?
Infinite.
Infinite. Very good. Right? X tends to. So what is this value? When x tends to positive value, something by infinity. This is 1 by 1 minus infinity. Something by infinity is what? 0. 0 when x is positive. And next one, when x is negative is what? This value, e power 1 by x is 0. 0 means what? This is 1 only. Got it? Once again, e power 1 by x value when x is going to 0 plus. That means positive values, e power 1 by x tending to infinity. So something by infinity is 0. When x is negative, e power negative value that tends to 0 when x is going. So when x less than 0, this value is 1. It is also not unique. Therefore, since limit is not unique, it does not exist. It does not exist. Okay, this is the concept of limit. Any doubts?